Good afternoon, everyone. My name is Tshegofatso Senona. Today, I'll be doing this talk with Khomotso Ngoepe. We are both a final year computer science student at the Tshwane University of Technology, and we are currently CSIR in service trainees. Today, we'll be taking you guys through the CTIP decentralization. CTIP, the abbreviation CTIP stands for Cyber Threat Intelligence Exchange Platform. So it is a platform that collects and shares security-related data. It uses intelligence from various sources for cyber threat monitoring and detection. Now, the aim of CTIP is to offer stakeholders with relevant indicators of compromise, strategies that they can use should they experience the kind of threat that other stakeholders have encountered, possible targets that they might encounter, and the threat actors that are actually threats to their organization. It also serves as a centralized nodal point. Now, this is a visual representation of the CTIP architecture. So, for example, you will have a CTIP, a stakeholder that encountered a threat. Then they will publish the threat to the CTIP, to the central CTIP, where the threat has been processed and filtered. And then now it will be distributed to different stakeholders. Now, the distribution also depends on the traffic light protocol that they would have selected to share to different stakeholders. The technologies that are used on CTIP as it's React.js, Django, and MongoDB. MongoDB is used for storing our data. Django is for the back end, and React.js it's used for the front end. It's that it had limited scalability, meaning that it can only take limited amount of requests. So should there be should the system experience peak period, that means it won't perform very well. So that means it also had one point of failure. So should the server go down, it means that the system won't operate at all, which makes it unreliable. So the solution that we decided to come up with on the CTIP system, we decided to decentralize the system. As you can see on the picture below, we have one client that is able to send requests to multiple, a cluster of servers. One might ask, why did we actually decide to decentralize the system? Decentralization helped us in terms of creating several servers. We were also able to create a cluster of servers running together to perform one task. For example, right now we replicated the servers, and also we were able to create a cluster of database servers that can operate together should there be a failover. It also helps us in terms of better performance on our system, and it also helps in intelligent fault tolerance policies, meaning that should you be on the system and one of our servers that you connected to, it shuts down, it means that your request will now be deflected to another server, but you won't be able to notice that. It also has a high availability and scalability with the servers that we have implemented on the system. So the approach that we took, we firstly replicated the existing servers, the existing server, and then we also introduced a load balancer to ensure that our servers communicate, and also we replicate the database servers.
With replicating the server, we take the exact copy of the existing machine, then create a new server based on the existing one. So as you can see on this picture, we have a 3 servers that are running on the different locations. So the server that's running on location 1 is a original server. Then the one that's running on location 2 and 3, they are copy of the server that is running on location 1. So this type of replication is called a peer-to-peer replication. So with peer-to-peer replication, these servers are not able to communicate. So to make them communicate, we introduced a load balancer and database replica. So one might ask, what is a load balancer? Load balancer is a software that is used to distribute incoming network across the servers. So you can take a load balancer as a middleman that is receiving requests and distributing it to the servers. So this picture demonstrates how does a load balancer work. So we have a client sending the request. So load balancer will receive and provide a better experience for clients. So as I mentioned on the last slide, that a load balance algorithm that we use is round robin algorithm. So round robin algorithm operate in an orderly manner. So this picture demonstrates how does a round robin algorithm work. So we have two servers and a 6 client. So let's say the client number one send the request. So run algorithm will be instructed to take that request and send it to server number one. So when the client number two send the request, so the load balancer will be instructed to send the request to server number two. So no, the server number two is our last server. So when the client number three send the request, load balancer will be instructed to send the server number three to server number one, and this process will repeat over and over again. So the load balancer software that we use is HA proxy. So HA proxy stands for high available proxy. So one might ask, why did you use a HA proxy? HA proxy improved the performance of the system. During the maintenance, there's no downtime, and it also gives access to integrate with server monitoring dashboard. So CTIP improve the system, high availability of our system, and it also mm, give it also load the request. It also balance the load. It also balance the request to the servers, and it also proxies for reverse HTTP. So this picture demonstrates how does the load balancer proxies for HTTP. So we have a client sending the request to the server. So the HTTP will receive the request. HA proxy will receive the request, then the request will be sent to one of our server, depending on the algorithm that is used. So the server will receive the request and generate the response, then the response will be sent back to HA proxy. So HA proxy will give the response to a client. So this is an example of a dashboard that HA proxy comes with. So this demonstrate we have two servers, all of them they are up. So it also show the total request, how long does the server is down, then yeah. So know that we load balance our servers and we replicated our servers and load balance our servers. So to make sure that our servers are on the safe state, we replicate the database.
Okay. Now that we have replicated our servers and we also introduced a load balancer to ensure that our 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 our, our database is on the same state, we used what we call replica sets. Replica sets are MongoDB instances. They ensure that our database is it's on the same state in all the servers. Now, how does the replica set work? Replica set works in terms of members. So you will have a primary member and then with the two secondary members. Basically, the primary member is responsible for reading and writing data. The secondary members are only responsible for reading and replicating data. So should there be a failover, your secondaries will therefore make an elimination between the two. I'll get into that later on. But then how do these members communicate? These members communicate in terms of heartbeats after every 2 seconds. So if a heartbeat does not reply within 2 seconds, within 10 seconds, the members mark that that member as inaccessible. And then if the primary is inaccessible in this case, because it's responsible for reading and writing data, therefore now an eligible secondary selects itself as the primary for reading and writing data. So now, how does it become eligible? It becomes eligible in terms of priorities. The one that has the highest priority, it's the one that gets to be selected to be your primary. Therefore, it's going to be responsible for reading and writing data. So if the cluster is now done with eliminating the secondary that is responsible for writing and reading data, your cluster closes and then operations continue as normal. This is a picture of when there is a failover with the primary. There's going to be a heartbeat communication between your secondaries, and a new primary will be elected based on the priority that you would have selected. So now with CT being decentralized and making sure that we have our servers and data is equally distributed, we have what we have analyzed is that the system it has high performance, and then it also it's reliable, and also again it is yeah, we can rely on it, and then it also it's able to render the services to the client should there be any point of failure, or should we want to maintain